So for the generation of these special kind of radiations, which are called as terahertz radiation, basically two main mechanisms are employed, and we are going to discuss one of them in this video, that is photoconducting antenna. This method is mostly employed for the generation of terahertz radiation, and the process includes the semiconductor substrate on which two metal contacts are placed, and a femtosecond laser pulse is made to incident uh, on this semiconductor substrate. Now what happens with the energy of the photons of the laser light? The electron hole pairs are generated in the semiconductor substrate, and what happens that these electrons, they conducts a charge. Now when these electrons are generated, and we are getting a electromagnetic field because of the laser is in itself a electromagnetic wave containing electromagnetic field. So this electric field uh, applies a force on the electrons which are generated as electron hole pairs in the semiconductor, and the electrons, they get accelerated. Now depending upon the duration of that pulse, the acceleration of the electrons is proportional to the time of the pulse, and as it is taken to be the femtosecond laser beam, the acceleration is such that the accelerated electrons of course produces Bremsstrahlung. They will emit radiation. The emitted radiation will be of the terahertz range. So what happens is the laser beam is coming, and the electric field of the laser beam is imparting a force. First of all, it is generating electron hole pair, and the electrons are getting accelerated because of the electric field of the laser beam, and the accelerated electrons are in turn emitting radiation. Now the frequency of that radiation falls in the terahertz range. Reason of this frequency range is because we are using a femtosecond laser pulse. So this is how traditionally and most of the time terahertz radiations are generated.